Hello there, my name is Alex and today I'm going to be demonstrating how you can make your very own JSON parser with ABparser. Now, this is essentially a part 2 to my ABparser tutorial, so make sure you've watched that video before you watch this one. Also, once again, if you can't hear what I'm saying at any point, this video does have subtitles, so feel free to use them. Okay, so if you're ready to make your own JSON parser from scratch with ABparser, here's how. Okay, so let's jump right into it. I would just like to say a few things about the JSON parser we're about to make. You've got to remember this is only a demo, meaning that the parser we're making won't have any error checking or anything like that. So just keep in mind that this is only a rough outline of a full JSON parser. So I've set this parser to parse to my own class called JObject and not a full object with reflection. And the only reason I'm doing that is just to make the demo much simpler. But there's no reason why you couldn't make it go into a real object. If you want an example of a full, complete parser made in ABparser, take a look at ABsave. As of me recording this, it's still a work in progress, but it still has the basic parsing to an object in there. There'll be a link to it in the description. Here's the object it will parse to. It's my own little object called JObject. All of the JSON things will inherit from this interface here. I also have an array, as well as a primitive for booleans, strings and numbers. I also have a pair which is used by the JObject, and an enum here for all of the different primitive types. And all of these objects here are what our parser is going to make. Right then, let's jump straight in and go over how we'll actually structure this parser. Now, we'll have 7 different tokens: object start, object end, array start, array end, string, pair separator, and item separator. These are all the important components of JSON, so we'll want to know when we come across one. In our parser, we'll also have 2 variables to keep track of where we are in the JSON. We'll have onValue, which will mark whether we're on the value of a pair or not, and we'll have inString to mark whether we're in a string or not. So that's all very simple. We've got our tokens and our booleans, but we need to actually store all the data somewhere. So what we'll do is we'll have an array of all the JSON items that we're currently in, as well as another array for where we are in each of those items. And don't worry, I'll go over what these 2 arrays are when we get to adding the functionality. We're going to call this parser JSON parser and make it inherit ABparser as usual. Now this is something that you really should do. A better way of setting up tokens is to actually make an enum for each one and then use nameof on it. I'll go ahead and do that now. I'll just call it JSON parser tokens and give it all the correct tokens. Now with that, we'll go into the constructor and actually set all of the tokens. But for the name, we'll now use nameof with the correct enum inside it. So you can see here that we're using the enum. Now this is a very good way of doing it, because it means that if I want to change the name of this, I can refactor this and it will change everywhere in the code. It's a better way of doing it than just having a string. So inString, which is used to detect whether we're in a string or not. We'll also use onValue, which is used to decide whether we're on the value or not. As well as current objects, which I won't go into now, but it essentially contains all the objects we're currently in. And followed by current object locations, which contains all the different locations we're at for each object. Now we also actually want to store the final result, and we'll do that in a small result variable. Also, we need to make sure that we actually initialize the variables every time the parser starts. So to do that, we'll just override on start and reset the current objects and the current object locations. So we're resetting everything. Now, in order for you to understand what I'm doing, we need to go over what these 2 arrays actually do and how they play a crucial role in parsing. This is actually almost the same as how ABsave parses stuff, except ABsave does it slightly differently because it goes into actual objects. So the current objects is an array of all the current objects we're in, right? So take a look at the JSON. Every time we enter an object or an array, we add an item to it, and whenever we exit an object or array, we remove the item from the array and place it wherever it needs to go. But now, what about the current object locations? Well, that stores where we are in each object. Let's lay them out at the bottom, and I'll just put a green box over here that says result. Now what I'm going to do is put up a fairly large JSON string here, and we'll see what happened with the two arrays. We go into the first curly brace. Now, ABParser knows that we've hit an object, but before it can put it anywhere, it needs to actually create the object first. So it adds a JObject to the current objects, and it also adds a new item to the current object locations. The second array tells us which pair we're on in whichever object it's next to. So in our case, we're on the very first pair, so we'll just put 0 in. Now there is actually a string token next, and the JSON parser would actually care about those, but I only want to demonstrate these two arrays, so we'll only worry about the tokens in green for now. We then go through and parse the first key and come across this square bracket. Now, this represents an array, so we add a JArray to the current objects. But we also need to remember which item we're on that array, so we'll add a new item to the current object locations as well. We skip ahead and come across an item separator. We've moved on to the next item, so we increment the one in the current object locations by 1. We continue on and come across a square bracket. Now this is the important bit. Now that we've completed the array, we need to put it somewhere. We actually need to put it in this pair here, which is found in this object at whatever location it was. Now this is why we need the second array. What we do is we take the JArray and we put it into the pair at the index highlighted in yellow. I'll just represent this with an arrow as we're kind of pushing it up into the object. And now that we've moved it up into the value of the current pair, we're done with the array, so we can go ahead and safely remove it. Now let's carry on. We come across this item separator, so that pushes us onto the next item in the current JObject. We go ahead and hit another one, so that increments again, and we continue, but now we've come across an object opening. So since we're creating an object, we need to build it before we can put it anywhere. So we go ahead and add an item to the current object as well as the current object locations like before. Then, skipping through all the other tokens for now, we come across this item separator and we go forward by 1 again. Once we get to the end of the object, we do the exact same thing. We take a look at where we were previously and we take the current object and place it there. And this will go on and on and on. And in a really large piece of JSON, you could have hundreds of items in the current objects. But the basic concept is still the same. Add, build, place, and remove. And when placing, it always goes directly into the item above it at the correct index. If we go back to our example, we now come across the final object end token. And this is where there's a problem. We go to place it, but it's the last item. There's nowhere for it to go, because there's no item behind it. Or actually, if you think about it, since this is the last object, this is the final result, so we'll put it into the result variable. We can then remove the item. So, essentially, think of it as a way of building up the object before we put it where it needs to go. Of course, with a primitive, we don't need to do that, since we just get it all in one leading or trailing instantly. Right then, that's how the very core of the parser will work. So, let's begin writing down all of the code. Let's start simple. We'll override the onToken process and just switch based on the name of the token. And now let's go through all of the tokens, except the string, and implement some basic logic for them. We'll gradually put more and more into them as we go along. We'll start with object start. Now we're going to add a new JObject to the current objects. And along with 0 in the other array. We know that if we're starting an object, the first thing we come across will always be a key. So we'll also make sure that onValue is false. Great, that's all we need there. Let's move on to the object end now. With the object end, we want to place the current object into the pair above it. But that's a bit tricky. Now, we're going to write a pretty big block of code that may be confusing. So just to make sure you're understanding here, if we do current objects.count -2, that's telling it to look at the second to last item, right? Also, if we want to find out what the second to last value is in the current object locations, we'll take it and we'll look at the second to last item, right? Right, now, when placing the item, you've got to remember that the item above it could be either a J object or a J array, so we can't just cast it. What we'll actually need to do is determine whether it's either a J object or a J array, and then set the value. So if it's a J object, we'll want to look at the second to last item in the current objects array and cast it into a J object. Then we can take a look at the pairs field on it, and we want to set it at the current location it was at. So we'll take a look in the pairs at the location it found in the second to last current object location, and then from that huge block of code there, we can then set the value to the current object, which is of course the last item on the current objects array. If you're really struggling with what I just wrote, it takes the current object and places it where it needs to go. Now we also need to do the same thing with the J array. It's almost identical there, except we're going to do it in the items field instead, and then we'll place that in. Now this entire thing is a huge block of code, and we'll be doing stuff similar to that a lot later on. So what I'm going to do is put it out into its own method. So you may not have known this feature in Visual Studio, but if you select code and do Ctrl+R, Ctrl+M, it will actually extract the code out into its own method and keep all the correct parameters and everything. Now I'm just going to call it finish item. And now that we've placed it into the correct location, we need to remove it. I'll also put this into the finish item method here. All we'll do is we'll just call remove at the correct item. And we'll also remove it from the current object locations array as well. Great, so we've done that. Now, this bit still looks quite messy. So I want to put this big chunk into its own method again. I'll call it setValue. But let's make it so that we can use it in other places as well. We'll make it take in a value, and then we'll set that instead of the last item. This just means that we can use it in other places as well. Now, if you ignore this method, you've got to say that that looks much nicer. I've actually got a bit of documentation on how I write my code, and that will be in the description below, but I think it does need a little bit of refining. Okay, now let's add the bit about how we're meant to place the last item into the result variable. Now, that can only happen if we're ending an object. So we'll put it in here instead of the finish item method. We'll just want to check if there's only one item. If so, we'll get it to set the result variable. Otherwise, we'll get it to place it into the correct location. We're going to do the array start now. We'll get it to add the J array first of all. And you've got to remember that everything in an array is technically a value. So we'll need to make sure that onValue is true. Now, I need to talk about how items are added to this array. So take a look at this array here. Now, every time we come across a comma, that's when we'll add a new item to the array, ready for whatever is after the comma. The problem is, there is no comma at the start. So when we come across the array start, we'll actually need to get it to add an item. But wait, then if we do that, then when the array is empty, it would be adding an item to it, which doesn't make any sense. So we'll need to add a bit of logic to determine whether it has items in it. Let's take a look at an empty array and how it's formed. It's just got the array start and the array end. Now, at first you might think, oh, just check if the trailing's empty. But let's say we have an object in there like this. In this case, the trailing would be empty, but there's still an item in there. So actually, in order to determine whether it's an empty array or not, what we need to do is also check whether the next token is the array end, which in this case it isn't, so we immediately know that it isn't empty. Let's jump into the code here. We'll add an if statement which will check if the trailing isn't empty, or the next token isn't an array end. And you can actually see here that in abparser, you can actually get the next token with e.nextToken. Once again, this is one of the many ways that ABParser can save you tons of work. Now we'll look at the name of this and check that it isn't an array n. If this condition is true, that means that the array isn't empty because we're using not equal to here. We'll add the first item in this case. And to do that, just look at the last item in the current objects array here. Now this is good, but there's a slight problem with this bit here. You see, even if there's a little bit of white space, this entire thing becomes invalid. So what we need to do is add trim, and that tells it to remove any leading white space that it can find. Great, that's actually one of the more complicated parts of this parser finish. So hopefully you understood all of that. Let's move on to the array end. There actually isn't much to do here. We just need to call finish item. Yeah, that's all we need. This one is really simple as well. All we need to do is set on value to true. Yeah, that's it again. And next is the item separator. Now, unfortunately, this one isn't quite so simple, because this is the bit that actually parses the value that came before it. For now, we'll just make a parse value method, and we'll add logic in here later. This will take in the string to parse and return the parsed object. Let's go ahead and call it up in the item separator. This will parse the value that it finds before, and now we need to place the value where it needs to go, which is in the last current object, and we need to cast that, and oh wait, this is almost identical to what we have down here, but there's a slight difference. This one down here actually sets the second to last, whereas we want to set to the current one, which is the last one. So here's what we'll do. We'll go down here and make a boolean called second to last. If this is true, we'll use the count subtracted by 2. Otherwise, we'll subtract by 1 here. Now, doing that may look a bit confusing, but I'll guess that you know how to use a ternary conditional operator. You know, the thing with a question mark and colon. All we need to do is go into the square brackets here and add second to last, followed by a colon, and then we'll go in and put a colon followed by count minus 1. And we'll do that in all of these spaces. Now, if this confused you, you could just put an if statement in here and then add an else and do all of the subtract by 1 there. But I'll just leave it as I wrote it, just to keep it all compact. Now up here, we can now call that, but with false passed in, and it will place the value into the correct place for us. And now that we've added that boolean, we also want to adjust it down here, but with true passed in, since this wants to set it to the second to last object. But now there's another problem here. Take a look at the JSON on the screen here. You can see that the first value will work fine. It will go through it, and that will parse to the parse value method, and then place it where it needs to go. That's fine. But if we just skip ahead here, to the end of this object here, and we go through the comma, there's now a problem. The leading has nothing in it, because there isn't anything in between the array end and the item separator. But wait, we've already placed the object where it needs to go, because remember, when we come across the object end, it puts it in the correct pair already for us. This means that actually, we don't need to do anything. Can you see how this is kind of designed? Now, you might think, oh well, that's fine, we can just leave it as it is. But the parse value would either throw an error, or, worse yet, it might return null, meaning the data that's already in there would get overridden by the null value. So actually, we need to add an if statement to check that the leading isn't empty. Now, don't forget what I said earlier about white space. We need to make sure that you add trim in here so that it doesn't count white space. Now, this is looking a bit messy here, so let's move it out into its own method here. I'll call it parse value and place. And I'll also go ahead and add descriptions while I'm at it. Also, I want this to take in a string here, not the event args. And now this parser is looking pretty good. We just need to finish up things here and there. There's one more thing we need to do here. We need to move forward an item, since that's really the main point of the item separator. To move forward one, we just need to get the last item in the current object locations and increment it. Now, there's one more bit of logic we need for this item separator. When we're in an array, we need to add a new item. So to do that, we'll just check whether we're in an array. If so, we'll just add a new item. But if we're in an object, which is essentially the only other thing it could be, we want it to mark us as no longer being on the value, since the key is always after the item separator. And now we've completed all of the tokens. Well, except for the string, which we'll do in just a second. Now, the strings actually play a very important part with the pairs in an object. You'll notice that nowhere am I actually adding pairs onto the current object. That's the job of the string when it's found the key. The reason I'm doing it there and not in the item separator is because it's easier and more performant that way, rather than having to create the pair, then modifying the name, then modifying the value. We can just create the pair with the name straight away and add that. So let's go in and add strings. Now I hope you remember what I said about token limits in the abparser tutorial. You always need to set them in the before token process. We'll go ahead and add an if statement. We don't want to do anything unless we've actually come across a string token. And inside here we'll set up the token limit. We'll start by making sure that limit affects next trailing is turned off, so that only the contents of the string are affected. Then set the token limit to the current token we've come across. Now there's also one more thing we need to add to this if statement. We only want it to set the limit when we come across the start of the string, not the end, because otherwise we're going to set the limit for the first quote, and then the limit will be deactivated automatically, and then it will be activated again at the end of the string. And we only want the contents of the string to be affected. So we'll only set the limit if we aren't already in a string. Now remember, we only want to put the token limit logic in here, nothing else. The only real reason is to help separate everything out a bit. So let's go down to the main one and make it set in string to true there. And now once we've hit the second string token, we want it to do everything in there. So let's add an if statement right at the very top for in string. When we come in here, we know that we've come across the second string token. Now, we'll go ahead and put the switch and everything else into an else, and indent it a bit here. Within here, we'll start by making it so that we're no longer in a string. Now, if this string is in the name, we'll want to add a new pair. And if it's in a value, we'll want to call setValue with a new J primitive for the string. We'll have an if statement which checks whether we're in a value or not. If we are, we'll set the value and make a new J primitive for the string. We'll parse false since we want it to set the last item in the current object, which is the current object of course. And if we aren't, we'll just add a pair with the correct key. To do that, we'll just get the last item in the current object and cast it to a J object, since we know that it has to be a J object. Otherwise it wouldn't have keys in it. We have almost completely finished our parser. We just need to do the parse value and one other small thing. Inside the parse value, all we will parse are integers and booleans. Now, you can't forget about white space, so we want to trim both the start and the end so that we don't include white space. Now, we'll check them. We'll start with true and false. All we want to do is return a J primitive with a type of boolean and the correct value. Once that's been done, there are two more things that we could possibly have: null and numbers. For null, we'll just return, well, null. And for the numbers, we'll just parse it as a double. Now, just remember, this is only a demo, but in a real proper parser, you would use try-parse. With that being said, we'll just return a numerical J primitive. And now, there's one more thing we need to do. If you take a look at the array on the screen, take a look at the gap between this part and the end. You'll see that there's no comma at the end here, and that the last value will never actually get parsed. But it's an easy fix. We just have to go into finish item and call parse value and place. And we're all done. Let's test it. Now I'm going to test this string here. It's a fairly basic JSON object here, with 3 keys in it and then more objects and objects in objects and stuff. So I just threw this together in a few minutes. So let's use this. Why not? Now, for some reason, C# uses double quotes when you're using literal string with an @ sign. I don't know why, so whenever you see 2 double quotes here, that's actually treated as 1 in C#. So we've got this left over from the last AB parser tutorial. We'll just swap this out with JSON parser, and now stick the string in there. Let's take a look. Now, we're only interested in the result variable. You'll see it's a J object, and there are 3 pairs inside there. So let's check those. The first one has a key of hello, which is correct, and the J primitive for a string. The second pair is a J object, and it has 2 more pairs inside of it, which are all correct. You can see good is actually a number, which is good, and another obj is yet another object in here. If we take a look at that, we can see it has the 2 booleans, true and false. So all that is correct. Let's check the very last pair. J array, which is correct, and that it has 2 objects inside of it. And believe it or not, that's it. The entire parser complete. But now, since you may be confused, we're going to go through how the entire parser works, step by step, with this string. So, let's take a look. We'll keep an eye on the flags, the 2 arrays, and the result, as well as the actual location it's in, and what it's currently doing. For what it's currently doing, we'll just have a little description. Also, anything that's highlighted in yellow down here means that we can actually see all the pairs and items inside of it over here, so that you can get a deeper understanding of this. So we'll walk through the JSON we just had, of course, starting at the beginning. Let's go. Let's just highlight all the tokens in yellow here. Everything else we go past is leading and trailing, of course. So it enters the first curly brace, and it runs on token process, and this just adds a new J object to the current objects, and of course another item in the current object locations. I'll just highlight this item in yellow so that we can watch as items are added to it. Now we continue and come across the first key. Because it's a string token, the before token process will actually get called, and a token limit is set. We also go into on token process, so we will now set in string to true. So we continue on as usual. If there are any tokens in the string, they will get ignored. We come across the second string token, and of course, the before token process ignores it. Now we finish up with the string we were on. Now, because we came across a string and weren't on a value, we are now adding a new pair into the current object with the correct name, which is of course the leading. Then we come across the pair separator, and this will literally just set on value to true. Then we go across again, and the same thing happens with the string. What happens is that because it's on a value, it now sets the value of the newly added pair and creates a J primitive for a string. Now we come across a comma, and this tries to parse the value, but the leading is empty because that's already been done, so it doesn't do anything there. It just moves on to the next value by incrementing the current object location and by setting on value to false. We carry on all the way to the next key. The same stuff happens all the way up to the curly brace. A new pair gets added with the correct key, and we set on value to true. Now we'll go into on token processed and add a new J object, as well as a location to match it. Now, for now, we'll keep an eye on all the pairs in this object, and we carry on, and come across another key. This will add a pair to the current object, which is the brand new object. But now we go all the way to the comma and don't get stopped. That's because we have a number now, and since the leading isn't empty, this means the comma will parse the value and create a J primitive for number. We'll continue on until we reach the next key, where we create another pair. Now this curly brace here means that we'll add another J object onto the current object, and we'll take a closer look at this here. Now we go through and create a pair with the correct key and all, but once again, the comma does the processing since we haven't come across a token, and we set a J primitive for a boolean. So let's skip through all of this since you probably get the idea. Now this is the new part, we're ending an object here. When we end the object, what we need to do is place it into the value of the pair we were previously on. So let's take a little look at the object behind this for a moment. You can see that another obj pair, but no value. So we're going to put our current object in there using set value, and then remove it from the current object. Now that we've got the correct J object in our value, that's all finished. And the same thing happens here. We finish up with this object and it gets put into the correct value. Now we're left with one object. Now we carry on into our final part, an array. We go through the key and add a pair and all of that, but now when we come on across this square bracket, we add a new JArray to it. We'll keep an eye on the items inside it. Now, because of how it works, we actually check whether it has an item in it by checking the trailing and the next token, as you may remember. Now in our case, the next token is an opening curly brace, so we know that it has something inside it, and so we'll add a null item for a moment. Now this is all the same here. We go into this object and it adds a new J object to the current objects. We go through it and parse it, then we come across the curly brace. Now what it does is really simple. It just takes the J object and overwrites the null item. Then we come across the comma and we add a null item, since of course if there's a comma there has to be a value after it. And then the whole thing continues. We go through and add this object, then you can probably imagine what happens. We reach the array end and take the array and place it into the value of the correct pair in the object above it, as usual. And now after all of that, if we take a look at our J object here, we can see that there are all our keys and values. And now we come across the last curly brace. And when we do that, we place it into the result and remove it. And that is it. If you followed along, you just learnt how to make your own JSON parser, and really any parser. The main reason I wanted to go over how this parser works is because I want you to understand the concept of current objects. Because trust me, for any complex parsing you want to do, you will probably need to use this layout. Now, as I already said, for this JSON parser, you don't really need the current object locations because stuff is getting added dynamically anyway, and you could just modify the last item. But it's good practice to use it, especially for something like absave. You see, I know I'm going a little bit off topic here. absave actually saves to real objects. So what it does is that it uses reflection to essentially create a dictionary of an object and all the pairs and items in it. And that dictionary is essentially its equivalent of current objects. But then what it then does, if it's unnamed absave, it will just use the current object locations for that dictionary. It's not really that helpful in named mode, but it's still there for unnamed. Right, well, I think I'll be leaving it here. It was meant to be more of a demo of what you can really do with abparser, but I guess it kind of turned into a tutorial. One thing I do want you to remember is that this parser is missing lots of things, such as single quote strings or even error handling in fact. This was more of an outline of a JSON parser. So there you go. If you want to take a look at all of the great things I mentioned below, such as absave, which is my own format for storing data in, take a look below. And thank you so much for watching this video. Bye!